Odds are a numerical expression, always consisting of a pair of numbers, used in both gambling and statistics. In statistics, odds for reflect the likelihood that a particular event will take place. Odds against reflect the likelihood that a particular event will not take place. Unfortunately, the usages of the term among statisticians and probabilists on the one hand, versus in the gambling world on the other hand, are not consistent with each other. Conventionally, gambling odds are expressed in the form x to y, where x and y are numbers, and it is implied that the odds are odds against the event on which the gambler is considering wagering. In both gambling and statistics, the odds are a numerical expression of how likely is some possible future event. In gambling, odds represent the ratio between the amount staked by parties to a wager or bet. Thus, odds of 6 to 1 mean the first party is staking 6 times the amount that the second party is. Thus, gambling odds of 6 to 1 foot mean that there are 6 possible outcomes in which the event will not take place to every one where it will. In other words, the probability that X will not happen is 6 times the probability that it will. In statistics, the odds for an event E are defined as a simple function of the probability of that possible event E. One drawback of expressing the uncertainty of this possible event as odds for is that to regain the probability requires a calculation. The natural way to interpret odds for is as the ratio of events to non-events in the long run. A simple example is that the odds for rolling 6 with a fair dice are 1 to 5. This is because, if one rolls the dice many times, and keeps a tally of the results, one expects one 6 event for every 5 times the dice does not show 6. For example, if we roll the fair dice 600 times, we would very much expect something in the neighborhood of 100 sixes, and 500 of the other 5 possible outcomes. That is a ratio of 100 to 500, or simply 1 to 5. To express the odds against, the order of the pair is reversed. Hence the odds against rolling a 6 with a fair dice are 5 to 1. The probability of rolling a 6 with a fair dice is the single number 1/6 or approximately 16.7%. The gambling and statistical uses of odds are closely interlinked. If a bet is a fair one, then the odds offered to the gamblers will perfectly reflect relative probabilities. If the odds being offered to the gamblers do not correspond to probability in this way, then one of the parties to the bet has an advantage over the other. The fairness of a particular gamble is more clear in a game involving relatively pure chance, such as the ping-pong ball method used in state lotteries in the United States. It is much harder to judge the fairness of the odds offered in a wager on a sporting event such as a football match. History: the language of odds such as 10 to 1 for intuitively estimated risks is found in the 16th century, well before the discovery of mathematical probability. Shakespeare wrote, "Knew that we ventured on such dangerous seas, that if we wrought out life 'twas 10 to 1. Terminology: odds are expressed in the form x to y, where x and y are numbers. Usually, the word to is replaced by a symbol for ease of use. This is conventionally either a slash or hyphen, although a colon is sometimes seen. Thus, 6/1, 6-1 and 6-1 are all interchangeable. Odds against: when the probability that the event will not happen is greater than the probability that it will, then the odds are against that event happening. Odds of, for example, 6 to 1 are therefore sometimes said to be 6 to 1 against. To a gambler, odds against means that the amount he or she will win is greater than the amount he himself has staked. Odds on is the opposite of odds against. It means that the event is more likely to happen than not. This is sometimes expressed with the smaller number first, but more often using the word on, meaning that the event is twice as likely to happen as not. Note that the gambler who bets at odds on, and wins will still be in profit, as his stake will be returned. For example, if he bets £2, he will be given £1 plus his returned stake of £2, leaving him £1 in profit. Even odds. Even odds occur when the probability of an event happening is exactly the same as it not happening. In common parlance, this is a 50-50 chance. Guessing heads or tails on a coin toss is the classic example of an event that has even odds. In gambling, it is commonly referred to as even money, or simply evens. Evens implies that the payout will be 1 unit per unit wagered plus the original stake, that is, double your money. Better than worse than evens, the term better than evens varies in meaning depending on context. Looked at from the perspective of a gambler rather than a statistician, better than evens means odds against. If the odds are evens, and one bets 10 units, one would be returned 20 units, making a profit of 10 units. If the gamble was paying 4/1 and the event occurred, one would make 50 units, or a profit of 40 units. So, it is better than evens from the gambler's perspective because it pays out more than 1 for 1. If an event is more likely to occur than an even chance, then the odds will be worse than evens, and the bookmaker will pay out less than 1 for 1. However, in popular parlance surrounding uncertain events, the expression better than evens usually implies a better than 50% chance of the event occurring, which is exactly the opposite of the meaning of the expression when used in a gaming context. Statistical usage. In statistics, odds are an expression of relative probabilities, generally quoted as the odds in favor. The odds of an event or a proposition is the ratio of the probability that the event will happen to the probability that the event will not happen. Mathematically, this is a Bernoulli trial, as it has exactly two outcomes. In case of a finite sample space of equally likely outcomes, this is the ratio of the number of outcomes where the event occurs to the number of outcomes where the event does not occur. These can be represented as W and L or S and F. For example, the odds that a randomly chosen day of the week is a weekend are 2 to 5, as days of the week form a sample space of 7 outcomes, and the event occurs for 2 of the outcomes, and not for the other 5. Conversely, given odds is a ratio of integers, this can be represented by a probability space of a finite number of equally likely outcomes. These definitions are equivalent, since dividing both terms in the ratio by the number of outcomes yields the probabilities. Conversely, the odds against is the opposite ratio. For example, the odds against a random day of the week being a weekend are 5 to 2. Odds and probability can be expressed in prose via the prepositions to and in, odds of so many to so many on. Some event refers to odds the ratio of numbers of outcomes in favor and against. Chances of so many outcomes in so many outcomes refers to probability the number of outcomes in favor relative to the number for and against combined. For example, odds of a weekend are 2 to 5, while chances of a weekend are 2 in 7. In casual use, the words odds and chances are often used interchangeably to vaguely indicate some measure of odds or probability, though the intended meaning can be deduced by noting whether the preposition between the two numbers is to or in. Mathematical relations, odds can be expressed as a ratio of two numbers, in which case it is not unique. Scaling both terms by the same factor does not change the proportions, 1 odds and 100 to 100 odds are the same. Odds can also be expressed as a number, by dividing the terms in the ratio in this case it is unique. Odds is a ratio, odds as a number, and probability are related by simple formulas, and similarly odds in favor and odds against, and probability of success and probability of failure have simple relations. Odds range from 0 to infinity, while probabilities range from 0 to 1, and hence are often represented as a percentage between 0% and 100%. Reversing the ratio switches odds for with odds against, and similarly probability of success with probability of failure. Given odds as the ratio W, L, the odds in favor and odds against can be computed by simply dividing, and a multiplicative inverses. Analogously, given odds as a ratio, the probability of success or failure can be computed by dividing, and the probability of success and probability of failure sum to unity, as they are the only possible outcomes. In case of a finite number of equally likely outcomes, this can be interpreted as the number of outcomes where the event occurs by the total number of events. Given a probability p, the odds as a ratio is, and the odds as numbers can be computed by dividing. Conversely, given the odds as a number, this can be represented as the ratio or conversely from which the probability of success or failure can be computed. Thus, if expressed as a fraction with a numerator of 1, probability and odds differ by exactly 1 in the denominator. A probability of 1 in 100 is the same as odds of 1 to 99, while odds of 1 to 100 is the same as a probability of 1 in 101. This is a minor difference if the probability is small, but is a major difference if the probability is large. These are worked out for some simple odds. These transforms have certain special geometric properties. The conversions between odds for and odds against and between odds and probability are all Marr paragraph bias transformations. They are thus as specified by 3 points. Swapping odds for and odds against swaps 0 and infinity, fixing 1, while swapping probability of success with probability of failure swaps 0 and 1, fixing 0.5. These are both order 2, hence circular transforms. Converting odds to probability fixes 0, sends infinity to 1, and sends 1 to 0.5, and conversely. This is a parabolic transform. Applications: in probability theory and Bayesian statistics, odds may sometimes be more natural or more convenient than probabilities. This is often the case in problems of sequential decision-making, as for instance in problems of how to stop on a last specific event which is solved by the odds algorithm. Similar ratios are used elsewhere in Bayesian statistics, such as the Bayes factor. The odds are a ratio of probabilities. An odds ratio is a ratio of odds, that is, a ratio of ratios of probabilities. Odds ratios are often used in analysis of clinical trials. While they have useful mathematical properties, they can produce counterintuitive results. An event with an 80% probability of occurring is 4 times more likely to happen than an event with a 20% probability, but the odds are 16 times higher on the less likely event than on the more likely one. In some cases the log odds are used, which is the logit of the probability. Most simply, odds are frequently multiplied or divided, and log converts multiplication to addition and division to subtractions. Examples: example number 1, there are 5 pink marbles, 2 blue marbles, and 8 purple marbles. What are the odds in favor of picking a blue marble? Answer: the odds in favor of a blue marble are 2-13. One can equivalently say that the odds are 13 to 2 against. There are 2 out of 15 chances in favor of blue, 13 out of 15 against blue. In probability theory and statistics, where the variable p is the probability in favor of a binary event, and the probability against the event is therefore 1p, the odds of the event are the quotient of the two, or that value may be regarded as the relative likelihood the event will happen, expressed as a fraction, or a multiple of the likelihood that the event will not happen. In the very first example at top, saying the odds of a Sunday are 1 to 6, or, less commonly, 1/6 means the probability of picking a Sunday randomly is 1/6 the probability of not picking a Sunday. While the mathematical probability of an event has a value in the range from 0 to 1, the odds in favor of that same event lie between 0 and infinity. The odds against the event with probability given as PR. The odds against Sunday are 6-1 or A6 firsts are equals A6. It is 6 times as likely that a random day is not a Sunday. Example number 2, there are 5 red marbles, 2 green marbles, and 8 yellow marbles. What are the odds against picking a yellow marble? Answer: 7-8. Gambling usage. The use of odds in gambling arose to facilitate betting on events where the relative probabilities of outcomes varied. For example, on a coin toss or a match race between 2 evenly matched horses, it is reasonable for 2 people to wager level stakes. However, in more variable situations, such as a multi-runner horse race or a football match between 2 unequally matched sides, betting at odds provides more scope. In the modern era, most fixed odds betting takes place between a betting organization, such as a bookmaker, and an individual, rather than between individuals. Different traditions have grown up in how to express odds to customers. Fractional odds, favored by bookmakers in the United Kingdom and Ireland, and also common in horse racing. Fractional odds quote the net total that will be paid out to the bettor, should he win, relative to his stake. Odds of 4/1 would imply that the bettor stands to make a £400 profit on a £100 stake. If the odds are 1/4, the bettor will make a £25 on a £100 stake. In either case, against or on, should he win, the bettor always receives his original stake back, so if the odds are 4/1 the bettor receives a total of £500. Odds of 1 first are known as evens or even money. The numerator and denominator of fractional odds are always integers, thus if the bookmaker's payout was to be £1.25 for every £1 stake, this would be equivalent to £5 for every £4 staked, and the odds would therefore be expressed as 5/4. However, not all fractional odds are traditionally read using the lowest common denominator. For example, given that there is a pattern of odds of 5/4, 7/4, 9/4 and so on, odds which are mathematically 3/2 are more easily compared if expressed in the equivalent form 6/4. Perhaps most unusual is that odds of 10/3 are read as 100-30, because 10-3 could be confused with the race time. Fractional odds are also known as British odds, UK odds, or, in that country, traditional odds. They are typically represented with a slash but can also be represented with a dash, for example 4/1 or 4-1. A variation of fractional odds is used in craps. Here odds are expressed with the stake included. Thus fractional odds of 4-1 against in craps are represented as 5/1, and odds of 4-1 on is 5/4. Decimal odds, favored in continental Europe, Australia, New Zealand and Canada. Decimal odds differ from fractional odds in that the bettor must first part with their stake in order to make a bet. A figure quoted is the winning amount that would be paid out to the bettor. Therefore, the decimal odds of an outcome are equivalent to the decimal value of the fractional odds plus 1. Thus even odds 1 first are quoted in decimal odds as 2. The 4/1 fractional odds discussed above are quoted as 5, while the 1/4 odds are quoted as 1.25. This is considered to be ideal for parlay betting, because the odds to be paid out are simply the product of the odds for each outcome wagered on. Decimal odds are also favored by betting exchanges because they are the easiest to work with for trading. Decimal odds are also known as European odds, digital odds or continental odds. Moneyline odds. Moneyline odds are favored by American bookmakers. There are two possibilities: a figure quote can be either positive or negative. Positive figures: if the figure quoted is positive, the odds are quoting how much money will be won on a $100 wager. Fractional odds of 4/1 would be quoted as plus 400, while fractional odds of 1/4 cannot be quoted as a positive figure. Negative figures: if the figure quoted is negative, then the moneyline odds are quoting how much money must be wagered to win $100. Fractional odds of 1/4 would be quoted as a 400, while fractional odds of 4/1 cannot be quoted as a negative figure. Moneyline odds are often referred to as American odds. Moneyline refers to odds on the straight-up outcome of a game with no consideration to a point spread. Gambling odds versus probabilities. In gambling, the odds on display do not represent the true chances that the event will or will not occur, but are the amount that the bookmaker will pay out on a winning bet, together with the required stake. For instance, if the bookmaker offers odds of 4-6 against a certain horse winning a race, this means that he'll accept a $6 stake in return for a payoff of $4, plus return of the stake, if the horse wins. If the horse loses, the bookmaker keeps the stake. In formulating his odds to display, the bookmaker will have included a profit margin, which effectively means that the payout to a successful bettor is less than that represented by the true chance of the event occurring. This profit is known as the over round on the book and relates to the sum of the odds in the following way: in a 3-horse race, for example, the true probabilities of each of the horses winning based on their relative abilities may be 50%, 40% and 10%. The total of these three percentages is 100%, thus representing a fair book. The true odds against winning for each of the 3 horses are 1-1, 3-2 and 9-1 respectively. In order to generate a profit on the wagers accepted by the bookmaker, he may decide to increase the values to 60%, 50% and 20% for the 3 horses, representing odds against of 4-6, 1-1 and 4-1. These values now total 130%, meaning that the book has an overround of 30. This value of 30 represents the amount of profit for the bookmaker if he accepts bets in the correct proportions on each of the horses. The art of bookmaking is that he will take in For example, $130 in wagers and only pay $100 back no matter which horse wins. Profiting in gambling involves predicting the relationship of the true probabilities to the payout odds. Sports information services are often used by professional and semi-professional sports bettors to help achieve this goal. The odds or amounts the bookmaker will pay are determined by the total amount that has been bet on all of the possible events. They reflect the balance of wagers on either side of the event, and include the deduction of a bookmaker or Euro unregistered trademark's brokerage fee. Also, depending on how the betting is affected by jurisdiction, taxes may be involved for the bookmaker and/or the winning player. This may be taken into account when offering the odds and/or may reduce the amount won by a player. See also, Galton box, gaming mathematics, formal mathematical specification of logistic regression, mathematics of bookmaking, odds algorithm, optimal stopping, statistical soccer predictions, references.